on the back side of your 7.5 notes, yesterday we worked an example there. It's that second one. We worked that together. We got two answers, correct? Okay. Well, let's go back and practice or see what we did for checking those to make sure that those were actually correct. And what we should have done is taken the 10.39 and plugged it back into the original problem, right? So to check this, we would say we have the natural log of 10.39 minus 3 squared, and that should equal 4. Okay? Well, you want to make sure that you tell the calculator that you want it to square that stuff first, right? We don't want the natural log squared. We want the stuff that's in the natural log squared. All right, so put in an extra set of parentheses in there. And when you do that, we should be getting 4.000 something something something. It's awfully darn close to 4. Okay? So is it a correct answer?
Yeah.
Yeah. Why are we okay with it not being exactly 4?
It's as close as, almost as close
Because we approximated.
That's what I'm looking for. We approximated our answer. We rounded to 10.39. That's not an exact answer. That's an approximation. Okay? So therefore, our final answer, when we check it, should just be awfully darn close. Okay? Well, what about the second one there? What if I plug in the natural log of negative 4.39 minus 3 squared? Okay, you're getting error. Did you go through and put in your second set of parentheses?
Yeah.
If you did, you probably didn't put them in the right spot because we should not be getting an error. Try it again. We should get the same exact thing, that 4.000 something something something, awfully darn close to 4. Right?
Yeah.
Okay. Now, here's something I want you guys to pay attention to. If I take a look at that problem, that natural log of negative 4.39 minus 3 squared. What is negative 4.39 minus 3? Okay, so that's what we're calculating here. Now, if you look back at your 7.4 notes, the front page of your 7.4 notes, we had a property then that said if we have log base b of, I believe it was m to the n power, that gave us n times log base b of m, right? Okay, so shouldn't I be able to take this exponent and throw it out in front? Right? And when we plug this into the calculator, remember the original one, we plugged that in, we got 4.000 something something something.
Do you still put an extra parentheses?
No, we don't need to in this case. We're taking 2 times the natural log of negative 7.39.
So you keep saying don't add. I did put parentheses.
It doesn't matter how many extra parentheses you try to put in here. It doesn't matter if you make sure to type in your multiplication in between there.
Yeah.
It's not going to matter. Because just type this in. What is the natural log of negative 7.39?
Error.
It's an error. Why?
Because there is no natural.
Why? What is that trying to calculate? Not a negative exponent. You're kind of on the right track, though. What's our base of a natural log?
10.
No. E. Natural log is base E. So this is trying to calculate E to what power gives us negative 7.39. Can I take a positive number? Because remember, e is a positive number, right? It's 2.72. Can I take a positive number, raise it to a power, and get a negative number as my answer? No. We said this before, that you can never, ever take any logarithm, any log base anything of a negative number. Can't be done. I had you write that down. I believe it was in your 7.3 notes. I had you write down that property. Log base b of anything negative is undefined. Can't do it. Okay? So my question to you is, or what I'm trying to point out to you here, why did this work, but this didn't?
Because you're squaring a negative.
Right, I agree. I'm squaring the negative, it becomes positive.
Oh, wait.
But why is that property not working for us? I thought those properties always worked. Look at your 7.4 notes. Look at the properties. And would somebody please read to me the first couple of words above those properties?
For any positive numbers, m, n, and b, where b.
For any positive numbers, m, n, and b. Well, is that a positive number? No. So those properties don't apply here. I cannot rewrite it this way. Okay? Which means I have to go through and I have to tell the calculator I want those extra set of parentheses there so that the calculator knows that I want the natural log of negative 7.39 squared.
When you square it, wait. If you square it, it doesn't give you a positive number, does it?
Negative times a negative is a positive. Has been for a long time. Okay?
Squared it doesn't. You had to put a parentheses.
Type it in the way I have it written. This brings up another good point, folks. Brings up another good point. Please remember there is a huge difference between negative 5 squared and negative 5 squared. Huge difference. This, the correct answer is negative 25. This, the correct answer is positive 25. Because remember, in that first problem, only the 5 is being squared. But in the second problem, the negative is coming along for the ride. You've got to remember those things. So, we want to tell the calculator that we want to square the negative 7.39 first to make it positive, then take the natural log. This is very different than if you just typed it in like this. If you told the calculator that, the calculator is going to assume that you want it to take the natural log of negative 7.39 and then square the answer. That is not what you want. Again, this one you should be getting an error. Okay? Excuse me. So make sure that you know how to use your calculator. Make sure that you know the little subtleties of the notation so that you can make sure to get the correct answer. Okay? Questions on this process? Again, I'm trying to tie things together for you guys. Those properties that we learned in 7.4 for expanding and condensing logarithms, those really only apply if, like it says, those letters A, B, and M, B, and N are all positives. If you have a negative in there like we did in this problem, you can't do that. You can't use those properties. Okay? Any questions? To the bottom of that page, 7.5 notes on the back side, on the bottom, we have two examples down there I'd like to work today. All right, the first one is this. Now, the issue we have here is that we have two logarithms. We never dealt with two logarithms yesterday. Okay? So does anybody have an idea of what we might need to do here? Yes, sir?
You subtract
Log x?
Yeah.
Okay, I think that would be a good idea, but it brings us up to some problems. If I subtract log x, then I end up having a log of that something, the x minus 3, equal to 1 minus log x. Okay? That log on the right side is still not by itself. And so when I exponentiate, the 1 is going to come into problems. It's not going to cancel with the log like it did last time. Okay, so that isn't going to help us. What do you think?
Would you subtract the 1 and then combine it like we did in the last section?
Okay, I like the combining it thing, but we don't have to subtract the 1. Okay, because we can't combine the 1 with the logs because it's not log of 1. It's just a 1. But I do like the idea of combining it like we did in our 7.4 notes. So, if we have logarithms with the same base added together, how do we combine them? We multiply these two pieces together. So we now have log x minus 3 times x. Okay. Well, yesterday we learned a $1 million word for what we're going to do next. Exponentiate. We want to exponentiate both sides. What are we going to use for our base? 10. Why? Because that's the base of our log already. If the base of our log was 2, we would use the number 2. If the base of our log was 7, we would use the number 7. But the base of our log is 10, so we need to use 10. So it's 10 raised to that logarithm equals 10 raised to the first. That's exponentiating both sides. And so now, essentially the log and the 10 go away, leaving us with x minus 3 times x.
But don't we also have a rule that says log base anything to anything that equals 1 to 0? Or is that, no?
No, you're putting that 1 in the wrong spot. We have a rule that says log base b of 1 equals 0. Okay? So yeah, that's not applying here. All right. So we now have this equation. So to solve this, to get x by itself, we're actually going to have to multiply stuff together. We're going to end up with a quadratic equation. So to solve this quadratic equation, we learned that we always have to do what?
Set it equal to 0.
Set it equal to 0. So you got to subtract the 10. And now we learned 4 methods for solving quadratic equations way back in Unit 1. Factoring, square roots, completing the square, and quadratic formula. We learned that we can solve by taking square roots only when we don't have an x term. If it's only x squared, we can take square roots and solve. Well, that doesn't apply to us here. We learned that we can solve by completing the square. That's something we haven't done in a long time. But we can only really use completing the square when this middle term is even. Right? Because then it's easy to divide it by 2 and keep moving on. It'll always work, but the work becomes much more complex. Okay, if that middle term is not even. So we can't use that method. So now we're down to 2 methods, factoring and the quadratic formula. Remember, the quadratic formula always works, but it's not always your shortest method. So let's try factoring.
It works.
Okay, now you're saying it works. Do we have to use that whole x method we learned, or can we use a shortcut?
Shortcut.
Why can we use the shortcut?
X squared is 1.
Because it is 1x squared. Because it's 1x squared, we can use a shortcut. If it was 2x squared, we can't use the shortcut.
Oh, yeah.
Okay, and all the shortcut says is that we're going to have x's in front of our 2 binomials, and that we're now looking for 2 numbers that multiply to give us -10, but add to -3. negative 5, positive 2. Very good. Okay, now that we have this, remember what we did? We broke them up. X minus 5 equals 0. X plus 2 equals 0. So then x must equal 5, and x must equal negative 2.
Check.
Got to check it. Let's plug them back in. Remember, you always plug it into the original equation. So we've got log of 5 minus 3 plus log 5, and that should equal 1. Well, what's 5 minus 3?
2.
So log 2 plus log 5. What's that give you? Gives us 1.
No.
So we know that x equals 5 works out. Well, what if we try negative 2? It's going to be log of negative 2 minus 3 plus log negative 2. That should equal 1. Well, negative 2 minus 3 is negative 5, right? So I've got log negative 5 plus log negative 2. What do we get?
Error.
Why? Because we just got done saying, folks, that we can't take the log of a negative number. Right? So as soon as you saw that you're taking log of negative 2, you should just stop and say, can't be done. So x equals 5 is the correct answer. And it's the only correct answer. Questions? Let's try one more. Log 6 minus log 3x equals negative 2. So, what do I do here?
Combine the log.
Condense it using division. Because remember, this time we have subtraction going on. So this is going to be log 6 over 3x equals negative 2. Can I do something here first before I keep moving?
Yes.
What can I do?
3 over 2.
Yeah.
Or 1 over
Simplify.
2.
Simplify is what you're trying to say.
2 over
And
1.
3 goes into both 6 and 3. So the 3 cancels on the bottom. On top we get a 2. So we have log 2 over x equals negative 2. Now what? $1 million word.
Exponential.
Exponentiate. What are we going to use for our base?
10.
10. Why 10? Because that's the base of our log right now. So 10 raised to that logarithm equals 10 raised to the negative 2. The 10 and the log go away, leaving us with 2 over x. And what's 10 to the negative 2 power? 1 over 100. Well, this right here, we have a fraction set equal to a fraction. Back in geometry, back in algebra 1, you learned these are called proportions.
Right.
These are called proportions. And you solve a proportion by cross multiplying. So therefore, I'm going to take x times 1 and 2 times 100.
Alright, let's check.
Test it. Log 6 minus log 600 equals negative 2. True story?
Yep.
Yeah.
Okay.
If it doesn't work, it's no solutions.
Right. Yep, if it didn't work, it'd be no solutions. Now, please remember that you don't have to cross multiply to solve that. It just takes extra steps. Okay, if you forgot that you could cross multiply, what you would have to do is multiply both sides by x first to get the x out of the denominator.
Oh.
And then you'd have to multiply both sides by 100 to get rid of the 1/100. Okay? So it works, it's just extra steps. All right? Any questions?